All right, good day. Welcome to today's webinar. Today we're going to dig a little bit deeper into FlowZ use cases, particularly around DevOps and modern integration. There's some previous survey webinars and podcasts available on FlowZ, and you can go back and listen to those, but we'll touch on the basics today as well. I am Dustin Froyum, one of the co-founders of VirtualZ Computing, and today I have Vince Ray, our CTO and co-founder, with me as well. Hi, Vince.
Howdy. Looking forward to the discussion today. Sounds like interesting topics.
Yeah. And then, so this will be available for playback on our YouTube channel or also our Skyward Data podcast, which is available on any of the podcasting platforms. We'll just talk a little bit about some of the challenges that we still see in the market around file and data movement. We'll do a little bit of the intro and architecture on flows, and then we'll dive into particularly flows with DevOps. And Vince, I'll be peppering you with the questions around that. Then we'll play a short demo where you can see how flows works in action. And I'll talk about pricing, and we'll get out of here. So anyone's been around the mainframe for some period of time, like we have, these things will sound familiar, right? Just challenge with historical, traditional data movement practices out of the mainframe, particularly if you're dealing with kind of file type items like vSAM or your backup files. And so, that can be very challenging to build those legacy ETL pipelines. You have to do scripting or some staging of data and conversion of data, even on your mainframe, then ship it out, then decide how you're going to ingest it in the target environment, or if you're going to do the transformation there. Which creates, costly maintenance activities, can be very one-off to a very specific file or data set versus something that can really service all of your needs on the mainframe. If you're doing one of the backup scenarios, those can be more complicated architectures when you're going out to SAN or cloud environments, or not even get out to a SAN environment. You need code on both ends, and pretty locked into a very proprietary system as well, somewhat like what you have on your mainframe already with your backup utilities and DASD or VTL systems. And then, that can be, you can be disruptive, or you can be time boxed into certain batch windows for moving that data versus being able to access them in your online window. And then, those can be very fragmented as well between, again, different types of data sets, different environments you're going to, so it can be difficult to, unify your data together. So Vince, can you just give us, a short overview of flows, the components, where it runs, how it works, and then we'll talk a little bit about DevOps.
Yeah, no, happy to do that. So flows is all about mainframe applications communicating with various types of either cloud or non-mainframe on-prem storage, using familiar standard paradigm. In other words, you can take pretty much any mainframe application that thinks it's talking to a sequential file, and without any changes to the application, without any changes to really anything on the mainframe side of it, flows can be configured to capture that data and communicate it to a cloud service of some sort. It could be an NFS server in the cloud. It could be an on-prem device. It could be Google Cloud Platform. It could be really just about anything. And by the way, one of the big advantages to flows is that the back-end interface that we use to talk to the target is open. So, other people besides us can write those. So if you need a particular target that, maybe we don't support today, that's a pretty easy thing to add into a flows environment. So, on the this is all ZOS software, self-contained on ZOS. You install it. It's a trivial install. I mean, literally a couple of minutes in most cases. You'll see this in the demo. We start with install and go through usage and some different use cases. But the idea is that that's all you need. You don't need software on the cloud side. You don't need a middle tier. You don't need any other bits and pieces in your environment. You just need FlowZ itself on your mainframe. Now with FlowZ in place, the way this works is really simple. As I said, you designate. You could think of it as a pipe. It's something in the local ZOS file system that looks and acts and behaves like a file, but really what it is an interface to flows. Application comes along, does normal open, close, read, write to that file system object. And what it's doing is it's talking to flows, and then flows in turn is talking to whatever it's configured to talk to. So it could be configured to talk to, various types of cloud storage, all the things I described before. And of course, many things going in parallel. So I can have one application going to, let's say the Amazon cloud, another application going to, an on-prem NFS server, another one going to Google, another one, whatever makes sense in your environment, you can do. The other thing is the data that flows through our product is able to be transformed in a variety of different ways. It's not just when you look at sharing mainframe data with other platforms, it's yes, part of it is just a connectivity problem. How do I get my data to other systems without writing custom code, or all the things that Dusty mentioned earlier in the presentation. But another part of it is about, once I get the data there, how do I get use out of it? Are my non-mainframe applications able to understand this data? And if it's, let's say a vsam file with a mix of text fields and binary fields and floating point and packed decimal and all these other data formats, that may be pretty hard for other applications to understand. So that's the other thing that FlowZ brings to the table. There's kind of a model there for doing that data transformation. It's based on uh, really the same technology we use in several of our other products. So it's proven, scalable, a way of taking a little bit of metadata that describes your records. Typically that's nothing more than something as simple as a COBOL copybook. Here are the field names and everything else, and we can derive what we need from that. So, this is actually very similar to our Propels product. So let me just spend a quick second distinguishing those two. Propels does many of these same things. The biggest difference is that with Propels, the output tends to be a relational database, or some type of database. So in other words, your data is being broken down into rows and columns, and you're going to use SQL queries or whatever the database supports as a query language to access that data. A lot of it is JDBC based. A lot of it is really a function of what kind of database do I want to go to. And in today's world, that's a great solution. FlowZ is more preserving the file architecture here. So it's not just about data record comes in and it's transformed to a row in a database. It's a record comes in and it's transformed and stored as a piece of a file. So your applications will continue to do open, close, read, write, not SQL query. So the other important thing is that FlowZ is bidirectional. So you could have, I don't know, maybe you do. Well, I mean, we're talking about DevOps. Maybe you have some test data that you want to feed into a mainframe application. With FlowZ, you could post that in, let's say Amazon S3, configure flows to work with that. And then, mainframe, let's say a COBOL program, can open that file, read it sequentially, process it like any other mainframe file. And now I'm doing data sharing really in both directions. It can be mainframe applications reading and writing distributed, non-mainframe data. It can also be non-mainframe applications accessing mainframe data. So it's all about preserving the file structure, and it's also about making it easy to share that data whichever way you go. So Dusty, what I forget to mention?
And Vince, this is no code on the target side. It's all on the mainframe, right? And
That's correct. Totally
and zip
self-contained.
eligible.
It's so yes, it is zip eligible for a portion of what it does. The portion really depends on the specific target that you go to, and it also depends on what the mainframe application is. So in other words, if I have a mainframe application that's, I don't know, let's say written in Java and it's otherwise zip eligible, all the things it does to access the file remain zip eligible. Under the covers, if I'm also using, and probably the best example is the work we did for the Google Object Storage. That's about, I want to say about 50–60% of that ends up being zip eligible. So it's really a hybrid approach. For best performance, we do certain things that are very ZOS specific that generally are not zip eligible, but a lot of the kind of network access and kind of the the basics, where we can do that in a zip eligible way, we do. It varies a little bit depending on what target you have. The things like Google and likely Azure and AWS will be the same way, but there'll be a much higher percentage zip eligible than, let's say, an on-prem NFS server would be. But again, you're free to mix and match that, and for the most part, it will definitely be fewer MIPS than competing technologies there.
Thanks, Vince.
Yep.
Let's dive a little bit deeper into the DevOps then, and then I'm going to ask you to maybe talk about it from a couple different perspectives. So, one is our customers, which they're most of them are going to have code repositories, build and deploy tools and processes, and then we also have partners, right, that are working on code migration, application modernization, or even developing net new code. And so, can you just kind of talk us through how FlowZ fits into those scenarios for us?
Yeah, and there are probably a lot of different scenarios here, and I'm going to talk to it from my perspective as an application developer, because I've actually used these things in our own environment. We just to provide a little flavor, we tend to use Microsoft's Azure DevOps as our kind of development platform, if you will. And so one of the challenges we run into is just integrating all of that together with the mainframe. Many of the tools we need to run, sometimes we use, like everybody else, we use things like Java that you can often build on Linux or other platforms. But we also have things like mainframe assembler language, or need to run the mainframe C compilers, and all of that. And because of those tools, we have this challenge of how do you get the inputs and outputs from them integrated with something like Azure DevOps. So, right off the bat, that's one of the big problems that I think a lot of folks run into. There are, some solutions out there from some of the other vendors, but if you dig into them, mostly what they do is they follow a replication model. In let's say I have some assembler language code that I want to integrate into my DevOps tool chain. I have this big problem that assembler code might depend on assembler macros, and there might be hundreds of them. And the assembler is really an old-fashioned mainframe application. It doesn't have, I mean, I generally can't even store those things in Unix services files, never mind in another platform, and never mind on something like GitHub or that type of source code repository. So right off the bat, there's this big problem of how do I get all of that done? And the usual answer is you just synchronize everything. You have a copy of your source, macros, all of that out in whatever your system of record is, and then you make a copy of it on the ZOS so that you can run your mainframe tools against that data. Well, in our case, we found it much easier to use things like FlowZ. What FlowZ lets me do is create endpoints on ZOS that use a driver that's specific to GitHub, so that when the mainframe assembler opens a file, what it's really opening is a file that's coming live in real time from GitHub in this example, or Azure DevOps in my example. So right there, to me, that solves an enormous part of the problem. I don't have to worry about checking things in and checking things out. And what if somebody's editing this particular assembler language macro and some non-mainframe tool somewhere? I don't have to worry about any of that. I just get the live data out of the source code repository, and it's joined directly with the tool that I'm trying to run on ZOS. And of course, it works the same way in reverse for the outputs. When that the assembler creates artifacts, all the mainframe tools to work pretty much the same way. You got the object code, you've got maybe debugging information, maybe all sorts of other things. Source code listings. I mean, there's a handful of things that are created. And again, my goal is not to store all of that on ZOS. I want to store that in a centralized place. So again, I can use FlowZ for that type of thing. And without writing any custom code here, what I've done is I've kind of linked these two worlds together at the level of the files that are involved, and I get I get all the benefits of both. It's pretty compelling when you go into, for instance, ISPF edit, and you point to a FlowZ endpoint that takes you to a GitHub source repository, and you're able to see and edit your source code directly from the mainframe. And then at the same time, I can do exactly that exercise with a much more modern tool on the non-mainframe side. I could use Visual Studio on whatever platform and see the same data in the same way, and all of a sudden, it gets to be kind of platform agnostic. Where I want to do my development really just depends on where the skills are. I have a developer who knows kind of the Microsoft tooling really well, he's free to do that. If I have somebody who knows kind of the legacy mainframe stuff, free to do that too, and they don't step on each other. That's really the first piece of the puzzle here. Doesn't really end there, though. It's much more than that. When you dig into complicated DevOps systems, it's also things like testing frameworks and generating test data and accessing test data, and all the things around uh, the life cycle of that application. So again, our flows approach lets us help with this quite a bit. We do, as you might imagine, we do a lot of testing of all of the products. And in every case, there are sometimes really large data files that need to be input into it, whether it's our FlowZ product or Propel's product, whatever it is. So again, what we can do is put those kind of resources under control of, again, in our case, it's Azure DevOps. But once they're there, they can be versioned, they're easy to update, they're, all of that. And then in kind of workflows where I'm doing the actual testing, which, again, in our case, is all triggered by Azure DevOps. We're launching these things right from the development platform. It ends up with something running on the mainframe that's using tools like FlowZ to access its inputs and outputs. So, really through that whole life cycle of how do I do development? How do I do testing? How do I do, all the different things that go on in the life cycle here? It's all assisted by, having a tool like Flows that can let us blur the distinction of what's on what platform and how do I access it. In our case, even the packaging of the products works this way. When we publish an update to really any of our products, what's really going on is an Azure DevOps pipeline is running, workflow is running. It might trigger some things on other platforms. It might trigger a bunch of things on ZOS to do the correct builds that we need, pulls all the artifacts together, does the packaging, does a round of automated testing, and promotes that to be our kind of new deliverables. So when you get a package from us, it's been through exactly what I'm describing here. So anyway, let me leave it there. I think maybe that's a good overview, but Dusty, anything you want to dig into more?
No, that was great, Vince. Yeah, let's play the demo now, and then we'll come out of the demo, and I think that'll give people a kind of a good view of, like you said, from install to operation. That demo is really kind of a storage use case, but you get the idea, right? It's just a slight variant of the DevOps is a slight variant of this demo. So let's play that now.
Welcome to the VirtualZ FlowZ demo. FlowZ is a exciting new mainframe software product that we've developed, and what it does in a nutshell is it makes it very simple, very straightforward to get mainframe data to just about anywhere, whether cloud applications, network attached storage devices, just about anywhere. So we don't usually talk about the installation process, but I just wanted to spend a minute on that and show how simple it is. What you see is just a normal shell session on my mainframe. I have the FlowZ distribution, as you can see, and all it takes is a single pax command, to explode that archive. It runs, and you'll see a directory structure, such as on the video. This is the FlowZ product is pretty much ready to go like this, and as you saw, it can be installed literally in seconds. So when we talk about you can be productive, the same day you receive the package, we're not exaggerating. It's one of the easiest bits of mainframe software you'll ever deal with. Now, in the demo today, what we're going to look at is we're going to be sharing some mainframe data with a SAN environment, and in this case, I have a physical SAN device that's set up to be network accessible to my ZOS system. What we're looking at here is basically the control panel or the desktop that comes with the software. In this case, it's running right in my browser. And what I've done up to this point is I've just configured it to have an NFS link to my mainframe. So what I'm going to do now is I'm going to go into the various shared directories and I'm going to create a new one. I'm going to create a folder that I'm just going to call FlowZ. And of course, it could be named anything. You could do this a lot of different ways. This is just one example. And of course, we can support lots of things beyond SAN environments. And you'll see we're starting with a nice, empty, clean directory. Now, back on my shell session, I'm going to do a little bit of setup work on ZOS. Probably the most important thing is I'm going to connect my mainframe to that folder that I just created. And this is done with a normal mount command. I can specify whatever file system name I want. That's just a logical name that ZOS is going to know this file system by. And, as I mentioned, it's NFS. So I'm going to specify that. I'm going to specify that I want read-write access. I'm going to specify where it appears in the ZOS file system /mount/NFS. And that parm is everything needed to connect. So my IP address and the name of the folder we just created, volume1 /shared/FlowZ. A lot of ways this could be done. This is just one example. You can automate this with FlowZ so that it happens under the covers every time a file is accessed. Totally up to you. Just showing this is kind of a simple way to understand what's going on here. So I've got my mount command. And, I'm going to enter that command and, fraction of a second later it works. It's authenticated me. It's, done all the things that our NAS device wants. And if there are any questions, I can use the, display file systems command. And I see /mount/NFS has a file system called FlowZ mounted on it and some other statistics. So with the mount point created, now I can use FlowZ to create, what I think of as a pipe, a local file system object on ZOS that's going to connect ZOS to that to that SAN resource that we just created. So I enter the command. You can see the output here. Nothing complicated. What I've done is specified the local name, the pipe file. That's the name that I'm going to reference the storage through. And I specified a target. In this case, it's a static target, but it doesn't have to be a static target. It could be a dynamic thing. Think almost like a GDG, that the name changes every time it's accessed. It might have the username, a date, whatever you need to be connected to it. And I see where it is, and I see that the creation of the object worked. If you ever have any doubt, we maintain the status of all of this. So, we see, FlowZ status will show us what we've created. If we've actually accessed data there yet, we would see byte counts and all of that. So I'm going to do a really simple thing. I'm back in a TSO session here, and I'm going to use some JCL to copy a little bit of mainframe data to that link I created. So I'm running, nothing even proprietary from us. I'm running the standard IBGen or IBM utility. My input is what you see, hello from ZOS, and the output is that object that I just created. So I submit this JCL. It runs nearly instantly. And now I've got data back on my SAN environment. Now let's go look at that. Back on the SAN desktop, I'm going to head back into the File Explorer here and see what we have. So again, this would look a little different depending on the kind of file you create. In this case, I open up, I'm still in that FlowZ shared file, and I see what we did. I see an 80-byte file called my file, and that's exactly the data that we sent to it with that JCL. You can see the properties, you can see the timestamps, security information, all of that is visible at this level. So, if I had another application, let's say running in the cloud that needed to reference this, that data is there for him, bit for bit. It's the same as what we put into the system with JCL in this case. certainly I could do it in a lot of ways. I could do it with command line functions. I could do all sorts of things. So, we've created I think of it as a trivial amount of data. Let's look at something maybe a little more complicated than that. What we're going to do now is we're going to create, same process. We're just going to create a different file. We're going to create something, and then we're going to take a system backup to this target. So I'm creating a pipe here called my_nfs dump, and I'm mapping it to my dump on my SAN device. You can see the results, same thing that we looked at before, just different names. And now I've got that object. So I'm going to go back again to TSO, and in JCL, I'm going to run IBM's DFDSS dump restore utility. Now, to make this work best with FlowZ, there are a couple of small JCL changes we make. First of all, instead of running the normal program name, we change that to FlowZ DSSU. It's basically just a small API example using DFDSS where we can load DFDSS and execute it through FlowZ, which allows us to capture the output and redirect where we want it. In this case, you'll notice I have a step lib. I mean, that's totally up to you. I mean, you as part of the install, you'll see how in the README file you would create this program. It's just running a link edit job. But the key is that I create a special DD statement, FlowZ dump, FLZ dump. And I point that, again, just like we saw with IBGener, I point that to the dump that I want to create in the network attached storage device in this case. Beyond that, it's just standard stock DFDSS. If I wanted to, I could write the dump in parallel both to a local file, maybe I want to, a virtual tape or whatever else, as well as in SAN device. I absolutely could do that. In this case, I'm just using DD dummy because, frankly, we don't have the disk space to hold duplicate copies of the dump. But the control statements, we're taking a disk volume called B3res1 that happens to be a 3390. We're going to take a full volume dump of it, and we're going to use the hardware compression feature on the system that I'm on. And again, all of the DFDSS control statements, everything about it is exactly the same. It's just that we ask you to change the program name so we can intercept some of the I/O that would normally go to tape or whatever it is. So I submitted that JCL. We can kind of watch it run. I mean, this is a 3390 disk volume, so it's in the order of a couple of gigabytes. We can see it running here. It's chugging along. It's doing its thing. We can see thousands of IOs per second being issued here. And we actually can look at the output, and just to confirm what I said before, you'll see the bottom half of the screen shows just standard DFDSS, and that's it. It's done at this point. In our testing, we find that a 3390 disk volume can be dumped to our SAN device in about a minute and 20 seconds. If I look at the output here, I see exactly that. I see a minute and a minute and 24 seconds. So, and again, keep in mind our development environment is a very small, very, very limited system. If I toggle back to the SAN desktop, I see the dump that we just created. I see that it's 1.63 gigabytes written in the time that we were looking. And again, I want to be clear, we're running on a Z PDT system. It's basically ZOS running on an Intel hardware processor, a desktop PC. The SAN environment we have is a little baby thing that we do testing with. It's not like industrial grade anything here. So, we did dump that 1.63 gigabytes in about a minute. And it is exactly what we expect it to be. I could do as many of these, as few of these as I want to. So, that's the quick version of the demo. You've seen what we support in terms of targets. You've seen how to use it, how the installation works, and maybe even gotten a sense of the performance potential here. We look forward to hearing from any of you. If you have any questions at all, want to see different demos, have a technical conversation with us, by all means, don't hesitate to reach out. Thank you.
Okay, thanks, Vince, for putting together that demo for us. I hope that was informative to everyone. I just want to talk a little bit about, and we've touched on many of these, but just some of the other use cases, and really one of the main ones is, and there's a whole webinar on this in particular, but seeing the backup and recovery scenario for using Propels, getting to SAN and the cloud without having to have, a third mainframe site or another mainframe site with DASD or VTL systems. And so it gives you a lot of flexibility to have additional copies and backups of your mainframe that are, air gapped and have, are in distinct operating environment, especially with people doing, almost asynchronous or asynchronous data replication across mainframe sites. So it gives you some fallback in your data, particularly to protect against ransomware and any other corruption that may occur. I want to talk a little bit about the pricing. So all of these use cases can be accomplished for a flat rate of $50,000 per year. That price is good through the end of 2025. And then there's a potential price change in 2026. So if you're interested in getting in on this price, please contact us. That is for unlimited installs, unlimited amounts of data. So it really serves all those use cases and your enterprise for that $50,000. And if you're interested in locking in that $50,000 for multi-year too, we can certainly do that. Just a little overview of all of our products. We can solve just about any mainframe data access and data sharing scenario. And Vince, you can attest this. We have some great customers that come up with some really interesting, challenging scenarios, but with just a little bit of tweaking or some pretty minor enhancements, we can meet just about every one of those scenarios. So Propels gives you real-time read-write. The mainframe remains the system of record. So if you need to share data outside of the mainframe, but don't want to do ETL or data replication, and you want to keep that data, securely in the mainframe, FlowZ is your did I say Propels? I meant LOZN. LOZN is your solution for that. Propels is a very high performant, no code data movement or ETL solution, creates direct access to the data and then moves it very efficiently and fastly to a target. The greatest use case there is, vSAM to some relational database and rows and columns, but we can take just about any input and then output target. There is also out of the box available for if you want to integrate mainframe console messages or SMF data into Splunk, and so there's a demo of that as well. You can see. We talked about FlowZ, and then Zach is another kind of higher order version of FlowZ and can run in virtual tape or virtual disk mode, depending on what your scenario is. So you can do that in SAN or in cloud storage. And so avoiding the need for, direct attached VTL and DASD systems. We'd love to hear from you. So if there's you want to trial any one of these products or talk about your use case, please reach out to us. You can do that through hello@virtualzcomputing.com, or there's a web form on our website. We have tons of resources out on our website too, blogs, links to all the webinars, the Skyward Data podcast. That includes both our webinars and we have some great guests that have been previously recorded. You can listen back to those just from industry experts in the mainframe world. All right. Thank you for joining us today. Thanks, Vince, for joining me as well. Hope you all have a great rest of your day.